Hey everyone, welcome back to our channel. If you're new here, don't forget to hit that subscribe button and the bell icon so you won't miss our future videos. Today, we're diving deep into the world of Snowflake with a comprehensive look at some of the most common interview questions you might encounter. Snowflake is a cloud-based data warehousing platform that's revolutionizing the way businesses manage and analyze their data. Snowflake offers unparalleled flexibility, scalability, and performance for storing and processing large volumes of data in the cloud. Whether you're a data analyst, a data scientist, or a business intelligence professional, Snowflake has something for everyone. Let's get started. What is Snowflake?
Snowflake is a cloud-based data warehousing platform designed to handle large volumes of data with ease and flexibility. It allows users to store, analyze, and share their data across multiple clouds and platforms.
How does Snowflake differ from traditional data warehouses?
Traditional data warehouses require significant upfront investment in hardware and infrastructure, whereas Snowflake operates on a pay-as-you-go model. Additionally, Snowflake separates compute resources from storage, allowing for greater scalability and cost savings.
Can you explain the concept of virtual warehouses in Snowflake?
Virtual warehouses in Snowflake are clusters of computing power that can be scaled up or down based on demand. They allow users to run queries and perform analyses without having to worry about managing underlying infrastructure. Here's an example query.
How does Snowflake ensure security and governance over data?
Snowflake provides various security features such as role-based access control, encryption at rest and in transit, and auditing capabilities to ensure secure handling of data. Users can also set up fine-grained access controls to restrict access to specific tables and columns.
How do you load data into Snowflake?
Data can be loaded into Snowflake using copy into commands, which support bulk loading of structured and semi-structured data from a variety of sources including S3, Azure Blob Storage, Google Cloud Storage, and local files. Here's an example query.
Can you explain how clustering works in Snowflake?
Clustering in Snowflake refers to the automatic organization of data by sorting it into micropartitions based on specified keys. This helps optimize query performance and reduce costs by minimizing the amount of data needed to be read during query execution. Here's an example query.
What are the advantages of using Snowflake's architecture?
Snowflake's architecture offers several advantages including elasticity, scalability, separation of storage and compute, and the ability to share data across multiple clouds and platforms.
How does Snowflake handle concurrency?
Snowflake uses a multi-cluster, shared data architecture to handle concurrency. This allows multiple users to run queries simultaneously without impacting performance.
Can you explain how Snowflake handles data replication and failover?
Snowflake automatically replicates data across multiple availability zones within a cloud region to ensure high availability and fault tolerance. In the event of a failure, Snowflake seamlessly fails over to a replica without any disruption to service.
What is the role of the Snowflake Optimizer?
The Snowflake Optimizer is responsible for analyzing queries and generating efficient execution plans by considering factors such as data distribution, statistics, and available compute resources.
How does Snowflake support semi-structured data?
Snowflake natively supports semi-structured data formats such as JSON, Avro, and Parquet, allowing users to store, query, and analyze these data types without the need for pre-processing or schema changes.
What are the different stages involved in query processing in Snowflake?
Query processing in Snowflake involves multiple stages including parsing, optimization, compilation, execution, and result fetching.
How does Snowflake handle data encryption?
Snowflake encrypts data at rest and in transit using industry-standard encryption algorithms and protocols. Encryption keys are managed by Snowflake and rotated regularly for added security.
Can you explain how Snowflake's automatic scaling works?
Snowflake automatically scales compute resources up or down based on workload demands, ensuring optimal performance and cost efficiency. This eliminates the need for manual intervention or capacity planning.
What is the Snowflake time travel feature?
Snowflake time travel allows users to access historical versions of data within a specified time frame, enabling point-in-time analysis and recovery from user errors or data corruption.
How does Snowflake handle data consistency?
Snowflake ensures data consistency through the use of multi-version concurrency control, MVCC, which allows concurrent transactions to access data without interfering with each other.
What is the difference between Snowflake Standard and Enterprise editions?
Snowflake's Enterprise Edition includes additional features such as enhanced security controls, advanced data governance capabilities, and priority support, tailored for large enterprises with complex data needs.
Can you explain Snowflake's approach to data sharing?
Snowflake's data sharing feature allows organizations to securely share live data with external partners or affiliates without the need for data movement or duplication. This enables real-time collaboration and insights across organizational boundaries.
How does Snowflake handle schema evolution?
Snowflake supports schema evolution through the use of schema on read, allowing users to query semi-structured data without predefined schemas. This flexibility simplifies data ingestion and analysis workflows.
What is Snowflake's architecture for data storage and processing?
Snowflake's architecture consists of 3 layers: storage, compute, and services. Data is stored in a scalable, compressed format, while compute resources are dynamically provisioned to execute queries and perform data transformations. Services layer provides metadata management, query optimization, and security functionalities.
What is Snowflake's approach to data partitioning?
Snowflake partitions data using a technique called micro-partitioning, where data is horizontally partitioned into smaller, compressed units called micropartitions. This enables efficient data pruning and improves query performance.
How does Snowflake handle data compression?
Snowflake uses advanced compression techniques such as run-length encoding and dictionary encoding to minimize storage footprint and reduce query processing time. Data is compressed automatically during ingestion and decompressed on the fly during query execution.
Can you explain Snowflake's Role-Based Access Control (RBAC) system?
Snowflake's RBC system allows administrators to define roles and assign privileges to users or groups. This granular access control mechanism ensures that users only have access to the data and resources required for their job roles.
What is Snowflake's data sharing feature and how does it work?
Snowflake's data sharing feature allows organizations to securely share live data with external parties by granting them access to specific databases or objects. Data sharing is done in real time and does not involve data movement or replication.
How does Snowflake handle data consistency across multiple regions?
Snowflake maintains data consistency across multiple regions using synchronous replication and distributed transaction coordination. Changes made to data in one region are propagated to other regions in near real time, ensuring consistency and availability.
What is Snowflake's approach to workload management?
Snowflake allows users to define workload management policies to prioritize and allocate resources based on workload importance and business priorities. Workload management policies can be configured to dynamically adjust resource allocation in response to changing workload demands.
How does Snowflake support data transformation and ETL processes?
Snowflake provides built-in support for data transformation and ETL processes through its SQL-based data manipulation language. Users can use SQL commands to transform data, perform aggregations, and load data into target tables.
What are Snowflake's options for data ingestion from streaming sources?
Snowflake supports data ingestion from streaming sources through integrations with platforms such as Apache Kafka and Amazon Kinesis. Users can use Snowpipe, Snowflake's continuous data ingestion service, to load streaming data into Snowflake tables in real time.
Can you explain Snowflake's Snowpipe service?
Snowpipe is Snowflake's continuous data ingestion service that automatically loads data from cloud storage or streaming sources into Snowflake tables in real time. Snowpipe eliminates the need for manual data loading processes and ensures data freshness.
How does Snowflake handle metadata management?
Snowflake manages metadata centrally and automatically tracks metadata changes for all objects within the system. Metadata includes information such as table schemas, column definitions, and data lineage, which are used for query optimization and data governance.
What is Snowflake's approach to data retention and purging?
Snowflake allows users to define retention policies at the table or database level to automatically purge data that exceeds a specified age or size threshold. Purged data is deleted permanently and cannot be recovered.
How does Snowflake support time-based data partitioning?
Snowflake supports time-based data partitioning by allowing users to define time travel periods for tables or databases. Time travel periods determine the duration for which historical versions of data are retained, enabling point-in-time analysis and recovery.
Can you explain Snowflake's materialized views feature?
Snowflake's materialized views feature allows users to pre-compute and store aggregated or summarized data to improve query performance. Materialized views are automatically refreshed based on defined schedules or triggered events.
What is Snowflake's approach to schema evolution for structured data?
For structured data, Snowflake supports schema evolution through the use of schema evolution policies. Users can define rules for handling schema changes such as adding or dropping columns, and Snowflake automatically applies these changes without requiring downtime or schema modifications.
How does Snowflake handle cross-database queries?
Snowflake allows users to execute cross-database queries by qualifying table names with the database name or by using the database.schema.table notation. Cross-database queries enable data analysis and joins across multiple databases within the same Snowflake account.
What are Snowflake's options for data export?
Snowflake provides multiple options for data export, including native export to cloud storage platforms such as Amazon S3, Azure Blob Storage, and Google Cloud Storage. Users can also use Snowflake's copy into command to export data in various formats such as CSV, JSON, or Parquet.
How does Snowflake handle time zone conversions?
Snowflake automatically handles time zone conversions based on session time zone settings and the timestamp data type. Users can specify time zones explicitly in queries or rely on Snowflake's default behavior to convert timestamps between different time zones.
Can you explain Snowflake's approach to data lineage tracking?
Snowflake tracks data lineage automatically by capturing metadata about data transformations, data movements, and data dependencies within the system. Data lineage information is used for auditing, compliance, and troubleshooting purposes.
What is Snowflake's approach to data sharing across different regions?
Snowflake allows organizations to share data across different regions using its global data replication feature. This feature automatically replicates data between regions, ensuring data consistency and availability. Here's an example query.
How does Snowflake handle data encryption keys?
Snowflake manages data encryption keys centrally using its built-in key management service, KMS. Encryption keys are automatically generated, rotated, and managed by Snowflake, eliminating the need for manual key management. Here's an example query.
Can you explain Snowflake's approach to data reclustering?
Snowflake allows users to recluster tables to optimize data organization and improve query performance. Reclustering redistributes data across micropartitions based on new clustering keys specified by the user. Here's an example query.
How does Snowflake handle schema changes for semi-structured data?
Snowflake supports schema evolution for semi-structured data by allowing users to query and process data without predefined schemas. This flexibility simplifies data ingestion and analysis workflows for semi-structured data. Here's an example query.
What is Snowflake's approach to handling semi-structured data formats?
Snowflake natively supports semi-structured data formats such as JSON, Avro, and Parquet. Users can ingest, query, and analyze semi-structured data using Snowflake's SQL-based interface without requiring pre-processing or schema changes. Here's an example query.
How does Snowflake ensure data durability and availability?
Snowflake ensures data durability and availability through its built-in replication and failover mechanisms. Data is replicated across multiple storage nodes within a region, and failover to replica nodes occurs automatically in case of hardware failures or maintenance events. Here's an example query.
Can you explain Snowflake's approach to handling nested data structures?
Snowflake provides native support for querying and processing nested data structures such as arrays and structs. Users can use dot notation to access nested elements within JSON or other semi-structured data formats. Here's an example query.
How does Snowflake optimize query performance for large datasets?
Snowflake optimizes query performance for large datasets by parallelizing query execution across multiple compute nodes. This distributed processing approach allows Snowflake to scale horizontally and handle large volumes of data efficiently. Here's an example query.
What is Snowflake's approach to handling temporary tables?
Snowflake allows users to create temporary tables for storing intermediate results or temporary data. Temporary tables are scoped to the session and automatically dropped when the session ends. Here's an example query.
How does Snowflake handle query optimization and execution?
Snowflake's Query Optimizer analyzes query execution plans and selects the most efficient execution strategy based on factors such as data distribution, statistics, and available compute resources. Queries are then executed in a distributed manner across compute nodes to maximize performance. Here's an example query.
Can you explain Snowflake's approach to handling user-defined functions, UDFs?
Snowflake allows users to define and execute user-defined functions, UDFs, using JavaScript or SQL. UDFs can be used to perform custom data processing tasks or calculations within Snowflake queries. Here's an example query.
How does Snowflake handle data consistency in distributed transactions?
Snowflake ensures data consistency in distributed transactions using a combination of multi-version concurrency control, MVCC, and distributed transaction coordination. MVCC allows transactions to access consistent snapshots of data, while distributed transaction coordination ensures ACID properties across distributed compute nodes. Here's an example query.
What is Snowflake's approach to handling user-defined roles and privileges?
Snowflake allows administrators to define custom roles and assign granular privileges to users or groups. Privileges control access to databases, schemas, tables, and other objects within the Snowflake environment. Here's an example query.
How does Snowflake handle workload isolation and resource allocation?
Snowflake uses virtual warehouses to isolate workloads and allocate compute resources based on workload requirements. Each virtual warehouse operates independently, allowing users to prioritize and manage resource allocation for different workloads. Here's an example query.
Can you explain Snowflake's approach to handling concurrent DDL and DML operations?
Snowflake uses a multi-versioned architecture to support concurrent data definition language, DDL, and data manipulation language, DML, operations. DDL operations are non-blocking and do not require exclusive locks on objects, enabling uninterrupted access to data during schema changes. Here's an example query.
How does Snowflake handle data skew in distributed query processing?
Snowflake automatically detects and mitigates data skew in distributed query processing by dynamically redistributing data across compute nodes. This ensures balanced data distribution and optimal query performance, even for datasets with uneven data distribution. Here's an example query.
What is Snowflake's approach to handling large-scale data transformations?
Snowflake supports large-scale data transformations using its SQL-based data manipulation language, DML, and integration with external data processing frameworks such as Apache Spark. Users can perform complex data transformations and analytics directly within Snowflake without the need for additional infrastructure or tools. Here's an example query.
How does Snowflake handle query caching and result caching?
Snowflake automatically caches query results and intermediate data within the compute layer to improve query performance for recurring queries. Cached results are reused for subsequent executions of the same query, reducing query processing time and resource utilization. Here's an example query.
What is Snowflake's approach to handling data retention policies?
Snowflake allows users to define data retention policies at the table or database level to automatically purge data that exceeds a specified age or size threshold. This helps organizations comply with data retention regulations and manage storage costs effectively.
How does Snowflake handle automatic scaling during peak workloads?
Snowflake automatically scales compute resources up or down based on workload demands to ensure optimal performance and resource utilization during peak workloads. This elasticity enables organizations to handle sudden increases in query load without manual intervention.
Can you explain Snowflake's approach to handling cross-database joins?
Snowflake allows users to perform cross-database joins by referencing tables from different databases within the same SQL query. Cross-database joins enable data analysis and integration across disparate data sources within the Snowflake environment.
How does Snowflake handle incremental data loading?
Snowflake supports incremental data loading using its merge command, which allows users to efficiently synchronize data between source and target tables based on specified criteria. Incremental data loading minimizes processing time and resource usage for data synchronization tasks.
What is Snowflake's approach to handling unstructured data?
Snowflake provides support for loading and querying unstructured data such as text, images, and documents using its variant data type. Users can store and analyze unstructured data alongside structured data within Snowflake, enabling comprehensive data analysis and insights.
How does Snowflake handle data lineage tracking for auditing and compliance?
Snowflake automatically tracks data lineage by capturing metadata about data transformations, data movements, and data dependencies within the system. Data lineage information is used for auditing, compliance, and troubleshooting purposes, ensuring transparency and accountability in data processing workflows.
How does Snowflake ensure high availability and disaster recovery?
Snowflake ensures high availability and disaster recovery through its multi-cluster, shared data architecture, and built-in data replication mechanisms. Data is replicated across multiple storage nodes within a region, and failover to replica nodes occurs automatically in case of hardware failures or maintenance events.
What is Snowflake's approach to handling workload prioritization?
Snowflake allows users to define workload management policies to prioritize and allocate resources based on workload importance and business priorities. Workload management policies can be configured to dynamically adjust resource allocation in response to changing workload demands, ensuring that critical workloads receive the necessary resources.
How does Snowflake handle concurrency control for data updates?
Snowflake uses optimistic concurrency control, OCC, to handle concurrent data updates by allowing transactions to proceed independently without locking resources. When conflicts arise, Snowflake automatically resolves them based on timestamp ordering, ensuring data consistency and integrity.
Can you explain Snowflake's approach to handling schema evolution for structured data?
Snowflake supports schema evolution for structured data by allowing users to alter table schemas without requiring downtime or data migration. Changes such as adding or dropping columns can be applied online, and Snowflake automatically maintains metadata consistency across schema changes.
What is Snowflake's approach to handling data deduplication?
Snowflake provides built-in support for data deduplication using its unique constraints and primary key constraints. Users can define unique constraints on columns to prevent duplicate values, ensuring data integrity and eliminating redundancy within tables.
How does Snowflake handle data isolation and security within multi-tenant environments?
Snowflake ensures data isolation and security within multi-tenant environments through its role-based access control, RBC, system and virtual private Snowflake, VPS, offerings. RBC allows administrators to define granular access controls, while VPS provides dedicated compute resources for enhanced isolation and performance.
What is Snowflake's approach to handling time-based data partitioning?
Snowflake supports time-based data partitioning by allowing users to partition tables based on timestamps or date columns. Time-based partitions enable efficient data pruning and improve query performance for time series data analysis.
How does Snowflake handle data governance and compliance for sensitive data?
Snowflake provides comprehensive data governance and compliance features such as encryption, access controls, and audit logging to ensure the security and integrity of sensitive data. Encryption at rest and in transit, role-based access control, and audit trails help organizations meet regulatory requirements and protect sensitive information.
Can you explain Snowflake's approach to handling data transformations using external services?
Snowflake supports data transformations using external services such as Apache Spark and AWS Glue through its External Functions feature. External functions enable users to invoke external processing engines and perform complex data transformations directly within Snowflake queries, leveraging the scalability and capabilities of external services.
How does Snowflake handle data masking and anonymization for privacy protection?
Snowflake provides data masking and anonymization features to protect sensitive information and preserve privacy. Users can define masking policies to dynamically mask or anonymize data at query time, ensuring that only authorized users can access sensitive information while preserving data utility and integrity.
What is Snowflake's approach to handling data replication between different cloud providers?
Snowflake provides native support for replicating data between different cloud providers using its cross-region and cross-cloud data replication capabilities. Users can replicate data between Snowflake accounts in different cloud regions or between different cloud platforms such as AWS, Azure, and Google Cloud Platform, ensuring data availability and redundancy across diverse environments.
How does Snowflake handle data lineage tracking for data quality and traceability?
Snowflake automatically captures metadata about data lineage, including data origins, transformations, and dependencies, to ensure data quality and traceability. Data lineage information can be used for data governance, data lineage visualization, and impact analysis, enabling organizations to maintain data integrity and compliance.
Can you explain Snowflake's approach to handling complex data types and arrays?
Snowflake supports complex data types such as structs and arrays, allowing users to store and query nested data structures within tables. Structs enable users to represent hierarchical data, while arrays provide a flexible way to store and manipulate collections of values within Snowflake tables.
And that's it for today's video. I hope this helps you in your preparation for your interview. Remember, practice makes perfect. So, keep practicing these concepts and queries. If you found this video helpful, give it a thumbs up and share it with your friends. Don't forget to leave your comments below. Until next time, keep learning and stay curious.